Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, the day's come. We're all done with our new 6SQ7 amp. This is the original. This is the one we just finished. The main difference, as you can see, is this has the larger laydown style transformer, and this one has a stand-up style transformer. This is about $40 cheaper. This is a lot easier to source. This one's really hard to find because it was a replacement for a Fender guitar amp. I think it was a Bassman or something like that. But anyway, ended up with voltages that were real close. With this amp, I ended up running a 5V4 rectifier tube to tone down the voltage just a little bit. Possibly don't need to. That's something I'm going to experiment with. This one we're running a 5AR4 or a GZ34, and the voltage is a little higher than what we've run before, but it's still within spec, so I went with it. And I'm going to show you how the higher voltage actually helped the distortion, which I knew that running the power tubes and the driver tubes at higher voltages sounded better, but I didn't have the equipment to actually measure them. Now with the Analog Discovery 2, I can measure it, and it's actually measurable improvement running higher voltages. So we're going to go over that. Going to show how to do the voltage checks on this thing. Going to probably do a different way of checking them. I've showed you, one way with the ground and the probe. This time I'm going to show you using some clip-on leads for people that have never done any voltage checking before. That's probably a safer way of doing it, but it's just a different way of doing it. It takes a little longer, but we're going to run with that this time, especially since we don't have to measure a lot of different voltages. The only voltage that we really have to measure is the plate on these as we power the amp up and pull it up on the variac. And then once we ensure that it's not going over 300 volts, we can power the amp off, hook the leads up to the cathode, and then check the voltage there to make sure it's right. We know it's going to be pretty close because we're biasing this tube with a 1.6 volt LED and a resistor, and I know it's the same thing I've used in this amp and some other amps, and so we're pretty sure that voltage is going to be safe. So we're going to pull it up on a variac, check the plate voltage on the 6SQ7s as we run up the voltage, and then once we do that, we're going to hook it up to the scope with the signal generator. Then we're going to hook it up to the Analog Discovery 2 and measure the harmonic distortion and then wrap up this video. I still, like I said, I need to hook this thing up to some speakers and listen to it, and I will probably cover that in the final video of some listening impressions, or initial listening impressions anyway, and report on if going with a simpler power supply with one less choke and one less filter capacitor has any impact on the amount of hum that's audible in the speakers when the amp's idling. So let's jump into the voltage testing. Okay, so we're ready to do some voltage testing on the driver tubes of this amplifier. And I know I showed you one way of checking these voltages. We're going to do a different way today. Now, if you've never done voltage testing on a high voltage device, and especially if you're kind of nervous about doing this, this is a different way of doing it that is, in my opinion, the safest way. It's a little more time consuming. I'm okay with using the ground lead and the probe method with one hand behind my back, but this method, you're never touching the amplifier when you're doing the voltage test, and it is, I'll admit, by far the safest way to do this. So let me go through how I do this. Got my variac here. Into that is plugged my isolation transformer. And you can see this is a fused one. It's got like a 1.5 amp fuse in here, so that if we have any kind of overload, and for some reason the amplifier fuse doesn't blow, this one will. If you look at the cord on that I'm using for this, you'll see there's no ground pin. Because we're using the isolation transformer, the amplifier is not grounded, so we don't have any ground connection here on the isolation transformer. We're going to make sure this stays unplugged while we're doing all of our connections. So that's going to sit right there. We get our voltometer, try to keep it in the camera, and this time we're using different leads. These little guys are made like this. When you push the end, the little hook comes out. And we're going to hook these onto the test points that we want to test in the amp, and then turn the power on. And so that way our hands are nowhere near the amplifier while we're working on it. So what we want to test here, we want to test the plate voltage we're going to do this tube first. So we put it right next to the pin that is the plate pin for that driver tube. And then we're going to come in here and we're going to hook this ground wire up to this ground lead for this big cap. So now we have our connections made inside the amp. They're clipped on, so we don't have to touch inside the amp while we're testing it. And now we're going to plug into our isolation transformer. And like I said, we've got this switch turned on. We're just leaving it on, and we're using the switch on the variac to turn everything on. So we're going to start off at about 90 volts and turn on the variac. And remember, we've tested the output tubes. We know that their voltages are all set correctly, so we don't have to worry about that this time. So we turn on the variac, and we wait till we start seeing some voltage. Now, if everything's working right, once things start conducting, we'll see the little LEDs come on the cathodes of the driver tubes. Going past 100 volts, and I'm starting to see the LEDs light up. And remember, 300 volts is the max for these 6SQ7s, and as long as it's under that, don't have a concern. Okay, so we've got 230 on the plate of the left channel driver tube. And again, we're not touching inside here, so I'm fine with just grabbing this knob and turning this up. Okay, there's 260. Now this is a little higher than the other amplifier was and what the schematic showed, because we're using a 5AR4 tube in this amplifier with a different transformer. And there's the mark that should be 120 volts. And we've got 265 volts on the plate of one of the driver tubes, and both LEDs are glowing pretty bright. So we know the tubes are conducting, and we've got the right voltage on the plate of one of the driver tubes. So now we're going to turn this down, turn this off, unplug the amp, and we're going to watch this until the voltage comes down, and under 5 volts is totally safe. We also want to give the capacitors an opportunity to drain good and the rectifier tube to cool off some, because if you short cycle a tube rectified amplifier like this, it can arc the rectifier tube and instantly kill it. Once they arc, then they become carbon tracked or whatever causes them to be susceptible to arcing again in the future, and they rarely are any good after they arc. So let's just wait another minute here. So again, we've got the cord unplugged from the isolation transformer, so we know there's no way we can actually accidentally turn the power on. We're under 5 volts. The other thing I didn't mention was I always hook up dummy loads to the output of a tube amplifier when I power it up. And these are the ones that I use. Got these off eBay, but several of the different vendors have them too. They look just like this. They seem to be pretty nice pieces, and they're more current or more wattage than we will ever need with the tube amplifiers we're working on. So then we come over here and connect to the plate of that tube. Ply our cord back in and flip on the variac. And the voltage will probably come up a lot quicker this time because we already have a partially warmed up rectifier tube. And again, we have it right at 90 volts. Both the LEDs are lit up. That voltage still looks well within the range. So let's go ahead and give it like 110. And again, as long as this is under 300, you know, if it went up to 280 or something, I wouldn't be concerned. And we got 265, which is well within the range of what those driver tubes are meant to run at. 250 to 275 is probably a nice sweet spot that's still very safe. So we know we've got the right voltage on the plates of both of our driver tubes. So off we go again. Unplug it and let the voltage come down. And this technique, you can see the voltage. And again, too, this is absolutely the safest way to be doing this. If you have any concerns whatsoever, this is the technique you should be using. I'm probably going a little overkill, waiting for it to come down under 5 volts, but this is also giving the rectifier tube time to recover, and you won't risk arcing and ruining your rectifier tube by getting in a hurry cycling the power. Speaking of which, the power outlet at my house has a device on it where if the power goes out for whatever reason, it unlatches a relay and the power can't come back on. So I don't know if you've ever had a situation where the power like blinks on and off. That can just destroy a tube amplifier. And so I'll cover that in another video sometime about devices that you can put in the wall out that will protect your gear from that sort of thing happening to it. So here we are. We're under 5 volts. And this thing's about to shut off. Let me cycle it. So this time, we're going to come over here and we want to see what the voltage is on the cathode. And it's going to be on the pin side of that resistor, because the power goes through the resistor, then through the LED into ground. So this will be checking the voltage at the cathode, which is the bias voltage for the amplifier. Since we know the plate voltage is rock solid, we know it's good, we don't need to turn down our variac. We can leave it on 120 volts. Make sure the switch is off, plug it in, and flip the power on. And we'll wait till current starts flowing through the tube. And we're looking for around 1.8 volts. Just a breath over 1.8 volts. It's exactly what we're looking to see. So the last voltage we want to check is the cathode on the other tube to make sure that that we've got tubes that are both conducting like they're supposed to, and that we've got the right resistor and LED combo to get the voltage where we want it. So off of the power, unplug the cord. Now this time, we don't know what the B plus is because we're now connected to a low voltage. And once the tube cools off, this voltage is going to drop off and the capacitors could still have a lot of voltage in it. Ideally, and I should have done this, I don't normally test this way, but probably be a good idea to have like a stopwatch or the clock on your phone and time how long it took the voltage to come down when it was hooked to those high voltage sources. And that's a good indicator of what it would take for it to drain in this situation. The other thing you could do if you have two multimeters, which not a lot of people do, and I'm not suggesting you go buy two multimeters, but if you do happen to have two of them, you could check the plate voltage and the cathode voltage on each driver at the same time, and then you'd be able to watch the plate voltage to know when it was safe to switch the leads over to the other two. So we're going to give this a minute. And I edited it out while I was waiting. So let's go ahead and switch this to the other cathode. It should be right there. Turn our meter back on. Now we're ready to plug this in. Turn our power back on. And this is our last voltage test point. If we get around 1.8 volts here, we're ready to toss this thing onto the analog scope and start looking at scope patterns. And it's climbing up. Fingers crossed. Leveling out. Just right over, just a little over 1.8 volts. It might ease on up to 1.81 volts, but that's perfectly fine. Anywhere from like 1.75 volts to 1.85 volts would work fine. This isn't super critical, but the closer you get to 1.8 volts, I feel like the better. It seems to be really a sweet spot for these tubes. So that does it. We've got our voltages checked. That's all good to go. We're ready to hook this thing up to the oscilloscope, inject the signal into these input jacks, and start looking what comes out the other side and see where the clipping starts. So let's get on it. Okay, I want to show you what's on my bench for doing my analog testing. This is an old Tektronix analog scope. It's a 2235 100 millihertz scope. This thing's ancient. I have no idea when this thing was made. I'd have to go look it up. Probably in the 70s, maybe the 80s. Anyway, it's been a real workhorse. I've used it for a lot of different purposes over the years and found that it works really great with tube amplifiers. And again, I'm hand holding this video, so I hope it's not too shaky. So here's our device under test. We have our dummy loads connected to both channels. Then I have the second channel of the oscilloscope hooked up to the right channel of the amplifier. And then over here, I have this old TEMA audio generator. It's a 1 megahertz. Let me see if I can see the model here. There it is. It's a 72455. This thing's worked really well. I bought it off eBay. I had to replace some of the capacitors in it when I first got it. It was kind of noisy signal, but once I replaced some of the old electrolytic caps, it started working great. It's got a knob here for changing the frequency, It's got push buttons here to change the range. It's got an attenuator that is stepped for the different ranges that it can operate in. And then it's got this amplitude knob, which you turn it up and down. What I really like about it is everything's analog. So like when I want to turn the signal up and down, there's a knob for it. When I want to change the frequency, there's a knob for it. I'm not pushing buttons and stuff. I know there's, digital ones that are a lot cheaper, but maybe I'm just old school. I like this old type stuff. So anyway, that's my setup. And the other thing that I do use is my isolation transformer. And I absolutely suggest you have one of these for working with a scope. The scope is always grounded. Do not float the ground on the scope. It's fine for the amp not to be grounded, but don't, when you're testing only, but don't have the scope ungrounded. Or use one of those 2-prong to 3-prong adapter things. Those are bad news. And here's our scope pattern, and the camera is freaking going crazy. So here's our scope pattern. I don't know what was making the camera go crazy. Maybe who knows. Anyway, here's where you can adjust the position, left and right. Try to get that centered. And I usually run it on, looks like this is 0.2 milliseconds. Have 5 volts on the probe that's going to the outputs on the amp. And then I have this one between 1 volts and 2 volts. 3 volts peak to peak will be line level. So there's our 1, 2, 3. And then we can go ahead and switch this to 2 volts and kind of get it out of the way. And then I'm going to go ahead and put the camera back on the tripod, and we're going to start testing this thing. So we're going to wrap up this video here. Tomorrow we're going to put this thing on the scope, get our harmonic distortion test done, do the final wrap up. One more video, and we are out of here. So, hope you're enjoying the series. If you are, please sub to the channel. Please like the video. And we'll see you soon for more 6SQ7 fun. Have a great day.